Welcome to LEGO Biomechanics. Today's topic, Radians. Happy Pi Day. I told you a couple weeks ago that I would tell you about radians and why they're so much better than degrees, and I can't think of a better day to do that than Pi Day. A good question to start with is, why do we divide a circle into 360 degrees in the first place? The best answer I've ever been able to find to this question is that the ancient Babylonians had a base 60 counting system and a tendency to approximate circles with hexagons. So when they were trying to devise a system for measuring the angles around a circle, it naturally occurred to them to divide it into 6 groups of 60, hence 360 degrees. I guess it works, but you gotta admit, that's pretty arbitrary. Certainly, we can do better. What if instead we used the arc length created by the angle? So if I use my LEGO Technic beam here for scale, you'll see this angle makes an arc length of 2.6 studs, this angle 3.9 studs, this angle 5.2 studs, a 90-degree angle is 7.85 studs, and if I go all the way to the 180-degree angle, that would be 15.7 studs. But what if I just made a larger circle? Wouldn't that change all the arc lengths? Yes, it would, but we can get around that pretty easy. All you have to do is divide your arc length by the radius. And that brings us to the definition of a radian. An angle in radians is the ratio of an arc length created by the angle divided by the radius of the circle. This has a couple of nice advantages for us. First of all, you'll notice that we're taking a length and dividing it by another length. So radians is technically a unitless, which will come in handy later when we get into talking about work, energy, and power. Another nice thing is that if we have an angle in radians and we know how far away from the axis of rotation a point is, we can rearrange this equation and find the arc length. This will come in very handy when we start relating the linear motion of a point on a rigid object to that object's angular motion. Here is a summary of some common angles in both degrees and radians. You'll notice that since 180 degrees equals pi radians, we have a tendency to express radians in terms of fractions of pi. So 90 degrees is pi over 2 and 45 degrees is pi over 4. Thanks for watching. Don't let anyone else eat your pie, and I'll see you next time.